Okay, I'm gonna try to record this video without a voice. See how it goes. So this lesson's on converting between the forms of quadratics. And so for the warm-up, we need to find the vertex. Okay, so if you have Desmos, you can type them in. You can do f of x equals or y equals. I'll do f of x. Okay, so the vertex is 5, 7. So if you didn't have Desmos, you would take the opposite of what's with x to get your x coordinate, and then take this number as your y coordinate. So because you see a -5, the actual x coordinate is +5. But leave the y the same. Here they want the solutions. And so if I type it in, the solutions are -1 and 3. And put them in brackets, curly brackets. Oh. Okay, so without Desmos, you just take the opposite of what you see with x. Okay, the other thing we need to review is box method. Alright, so 1 times 1 is 1. x1 times x1 would give you x2. Multiply the big numbers, add the little numbers. -5. 2 times 1 is 2. x1, and then 2 times -5 is -10. These are like terms, so we can add them together to get -3x. So my final answer is 1x squared minus 3x minus 10. Here, x plus 4 squared you can't distribute the square as the same as x plus 4, x plus 4. So same as before. We need a box. So this would be x squared, 4x, 16. That would give me 8x. So x squared plus 8x plus 16. Alright, so these are our three forms. Standard form, where we get A, B, and C. And then we have what's called vertex form, where we can take the opposite of this and then take this value for our vertex. Okay, so just like here, 5, 7. This is called root form because these numbers next to the minus sign, which you can view as opposite. When you see minus, think opposite. Where R1 and R2 are the roots or solutions or x-intercepts. Or we can call them zeros. All mean the same thing. Vertex, roots, okay, and so today we're just going to practice converting between vertex to standard and root form to standard. It's an important skill. So this is vertex form. We want standard form. So we see an x plus 3 squared. That's x plus 3 times x plus 3 with a minus 5 at the end. We need to do this first. Just like the warm-up. X plus 3, x plus 3. Give me x squared, 3x, 9. That's 6x. When you add them, combine your like terms. So that becomes x squared plus 6x plus 9. And then we have this minus 5. And so we can combine these two constants to get 4. And so our final answer, x squared plus 6x plus 4. that's standard form. A would be 1, B would be 6, C would be 4. Here, I'm going to rewrite this as 2x minus 5, x minus 5, because of the square. And then do this first. That's x squared minus 5x. And then positive 25. That would give us negative 10x when you add them. So we get x squared minus 10x plus 25. And then now we can bring back the 2 and the plus 7. Okay, next we have to distribute the 2. You can't add 7 until you distribute the 2. And the 7 does not get multiplied by the 2. It's not in the parentheses. And then lastly, we can combine the 50 and the 7 to get 2x squared minus 20x plus 57. So that's vertex form. This is standard. B would be negative 20. C would be 57. Here we have a 3 multiplied by these. Do these first. Squared 4x, negative 7x, negative 28. Add your like terms. Negative 3x. So x squared minus 3x minus 28. Put it back in parentheses. And bring this 3 back. Now distribute. $60 plus 20, 84. This is root form, standard form. That's A. B would be negative 9. C would be negative 84. All right, I'll do the fraction and let y'all check the key on the rest. Actually, yeah, I'll do this one. So take care of this first. I'm going to rewrite it. Okay, that's square. And then make a box. Positive 4. It's negative 4x. So this is x squared minus 4x plus 4. Put it back in parentheses. Bring your 1/2. Bring your plus 10. Distribute the 1/2. It's the same as dividing by 2. Now add 10 at the end. And that would be standard form. This was vertex form. Standard. Okay, this is root form. You need to get standard form. This is vertex form. You need to get standard form.